let's assume that we have the usual simple harmonic oscillator potential, m omega naught squared x squared over 2, and that we want to construct a superposition of three separate eigenfunctions of the Hamiltonian such that the expectation value of x does not depend on time. Right? We understand the symmetry properties of the eigenfunctions, and therefore we can construct this object. Psi of x and t will be some a, could be a complex number. Let's try to be general at this point. So we want three terms that let's call them psi m of x for the eigenfunctions here, e to the minus I m plus a half omega naught t plus a b coefficient, another number, another symbol representing some natural number, which we'll comment on, psi l of x e to the minus I l plus 1/2 omega naught t plus some c coefficient psi k of x, indicating an eigenfunction e to the minus I k plus 1/2 omega naught t, and of course a modulus squared plus b modulus squared plus c modulus squared has to equal 1. That's normalization, and so these are the weights. A modulus squared is the weight here. So we could have 1 over square root of 3, 1 over square root of 3, and 1 over square root of 3. Those would be real. That would be the simplest combination where they're all the same. So m, l, and k are, so these are natural numbers. They are all either even or all odd. Right? That will produce the evenness in the result in the probability. So we know that the probability of finding the object between minus x naught and x naught, in other words, psi modulus squared, is time independent. And of course, this is time independent as well. So this is true. Whereas, say, x naught over 2 to x naught, probability of finding the object there does depend on time. Right? There's definitely interesting cross products here that involve time, and so the probability density is evolving at different frequencies. Whereas we have multiple frequencies here in this object that involve the differences between these quantities. And so there's definitely an interesting time dependence here. In general, the psi modulus squared is time dependent, but when we integrate it, given the symmetries here, certain things are time independent, as we've seen for other potentials.